All right, welcome to lecture 2.2, Units and Conversions. Our goals here are to define and explain the SI units, be able to identify and use derived units for density and volume. I want you also to be able to calculate density and volume, and I want you to be able to convert units using conversion factors. These are our goals. Go ahead on your note paper and just write down these exercises. We're going to be doing exercise number 40 in the book, numbers 1 through 3. And in our problem-solving conversions workbook, we're going to be doing pages 3 and 4. This is assignment 9A, if you're looking for the number. Let's go ahead and write that down. We'll move on in just a moment. Okay, I want to talk about SI. Scientists all over the world have agreed on a single measurement system called the Le Système International des Units. I don't know how to speak French. I'm messing it up. Anyway, it's called the SI system. It has 7 base units. That means 7 very basic units. And most other units are derived from these 7. What is a unit? A unit is a symbol we put after a number to tell us what we're measuring. A very common one we're used to is the pound. I weigh 246 pounds right now, so that's 246 units called the pound. But the SI units are different. Let's check them out. For length, we have the SI unit called the meter. That is the base unit. These are other units derived from the base unit. For volume, we have the cubic meter. For mass, the kilogram, and for temperature, the Kelvin. These are all base units. What a kilo, the kilo in kilometer means 1,000. Deci in decimeter means a tenth. Centi in centimeter means 100th. Milli means 1,000th. Micro means, well, you get it, a millionth, and so on and so forth. But the meter is the base unit. How do you know what the base unit is? Nani meter, nani kilogram, nani, that's Japanese. Anyway, something unit.
What? What? What does abadaba mean?
Never mind what abadaba means. Okay. All right. This is something from your book. These are the base units: length, mass, time, temperature, amount of substance, electric current, and luminosity. Remember, I want you to know these and the symbol. All right, don't worry about that. Not important. Very interesting, but not important. So, what I'm going to ask you is, what is the unit of time? You'll say second. What is the unit of length? You'll say meter. What is the unit of volume? You'll say cubic, well, whatever it is, cubic meter. All right? So that's easy enough, I hope. SI base units, mass is the measure of the quantity of matter. Okay, this is interesting. Mass isn't the same as how much you weigh. Mass is the amount of stuff, amount of matter in you. You weigh different weights on different planets because of gravity's difference. On the moon, I would weigh less than I do here, but I would still have the same amount of matter in my body. On Jupiter, I'd weigh much more than I weigh here, because Jupiter has a lot more gravity, but I would still have the same amount of mass. Mass is a measure of the quantity of matter. It's confusing because on Earth, the only way we measure mass, at least right now, is with a scale. And we get the word weight and mass confused. But don't get confused. If I say, what's the difference between weight and mass, I want you to know that mass is the amount of matter, weight is the gravitational measurement of that matter. All right? Weight is a measure of the gravitational pull on the matter. Just said that. Mass does not depend on gravity. Any questions?
You have any questions?
Yeah. Yeah, you're right. All right. They're going to go through this real quick because we don't need to spend a lot of time on it. Length, measure of distance. The SI standard for length is the meter. The kilometer is used to express longer distances, means 1,000 meters. And the centimeter is used to express shorter distance. It's about the width of your thumb. Yeah. Come on. Derived units. Can everyone see? Derived units. Now, the word derived means to be made from or come from something else. So a derived unit comes from the base units put together in different ways. A combination of SI base units. Pressure is measured in units called kilograms for every meter times second squared, or pascals. Whew. Don't worry about that one. We'll learn about that one later. The ones I want you to know about are volume. I want you to know what volume is, and I want you to know what density is. Molar mass, molar volume, and area. Okay. So this is another table I told you about. What do I want you to know? I want you to know this one. I want you to know the derivation. How do you get it? How do you get to it? All right. So here's a simple example on the next screen. For example, volume. Volume is the amount of space occupied by an object. The derived unit is the cubic meter. The cubic centimeter is often used, and the liter is a non-SI unit. Okay, there's way too much information here. One, cubic meter. How big is a cubic meter? It's pretty big. I don't have a meter stick. Imagine my arms, that's about a meter this way, a meter this way, and a meter this way. That's a lot. And that's volume. Cubic. All right. Centimeter is this big. Cubic centimeter by cubic centimeter, cubic centimeter, a lot smaller. But it's the 3D thing. Okay? So I want you to know. So what is that? That means volume is length times width times height. Make sense? We write volume as the meter cubed because length is a meter, width is in meters, and height is in meters. So meter times meter times meter is meter cubed. Okay, and okay. Moving right along. Volume, skippity-doo-dah. Measuring the volume, skip again. Derived units. Density. Oh, yeah. Okay, density. Density is another derived unit. It's another combination of two. It's the combination of volume, what we just talked about, and mass. Density is how heavy. No. Density is how much mass is in one unit of something. Something that is more dense will feel heavier than something that is less dense. Alrighty then, so imagine in your mind a brick in your hand. It's heavy, it weighs about, I don't know, 4 or 5 pounds. Now imagine a brick of styrofoam, same size, different weight. That's density going on. That is mass over volume. How many units of mass are in each unit of volume? So the derived unit is kilograms per cubic meter, kg over meter cubed. What I really care about right here is that. I want you to know that. If you know that, you can figure that out later. Okay? Mass over volume is density. All right? Let's keep it moving. But here is a list of different substances with density. Cork is very light. It floats. It's only 0.24 grams per cubic centimeter. That doesn't mean anything to you guys. It doesn't mean much to me. You've never really, 200 cubic centimeters in my hands, whatever. No, but I just want you to know that mercury, very heavy, 13.6 grams for every cubic centimeter. Lead, heavy. Water, where's water? Right there. Oh, look at that. Water is almost perfect 1. You're going to find that water is a lot of things that's almost perfect 1. Anyway, let's keep moving. Then let's do a little practice-a-roo. Equation, skip. Okay, here's an example of the problem we kind of want to do. A sample of aluminum metal has a mass of 8.4 grams mass. Okay, the volume of the sample is 3.1 cubic centimeters. Calculate the density of aluminum.